So today we're going to talk a little bit about wood construction, properties of wood. Our kind of objectives for today are to discuss wood framing because it does make up 90% of residential construction. We'll take a look at its properties, the ramifications of those properties, and then we'll get into a little bit more application discussing the principles and practices of wood framing. So as a tree grows, there's different components. There's bark, a cambium layer, and sapwood, and those are labeled on the PowerPoint. You can take a look at those. But then there's also heartwood, pith, and then the annual growth. You're probably most familiar with annual growth with those rings. You used to count them as a child to see how old a tree is. So there are typically two major types of wood, hardwood and softwood. Softwood comes mostly from North American forests. It's faster growing, plentiful, relatively inexpensive. It's generally soft and easy to work with. You can use softwood for structural wood products, finish trim, shingles like cedar shingles on the side of a house, siding or flooring. Not all softwoods are completely soft. For example, a Douglas fir is actually harder than some hardwoods. Hardwood species are harvested from around the world and they're generally much slower growing. They're denser with a greater variety of colors and figures. And typically these are your more exotic woods. They're used for fine trim, paneling, flooring, cabinet work, and furniture. Most lumber in the United States for structural purposes for home framing is softwood. So when we're looking at wood materials and properties, moisture content is one area that we need to discuss very briefly. Moisture does impact the strength properties of lumber. 30% moisture is considered its natural state. The size doesn't change, the strength doesn't change. But if the moisture is below 30%, wood will actually constrict or shrink, but the strength does increase. However, it is going to vary in size. The term lumber refers to any wood that is cut into a specific size, specific shape to be used as building material. Rough lumber is sawn on all four sides but not surfaced or sanded. Dressed lumber has been surfaced on one or more sides. So when we're discussing strength of wood, lumber grading and those rules of strength are set by a National Grading Rule Committee. And the allowable stresses are determined by the species, the moisture content, and the grade. So not all wood is created equally. There are different types of wood with different moisture contents and different quality that affects the strength of the material. As we get into the idea of house framing in this picture that you can see here, a house frame typically employs studs, joists, and rafters, and we use those three components to form a building frame. Typically, when you hear the word stud, that is referring to the framing inside a wall. A joist refers to either floor or ceiling support, and rafters are part of the roof structural system. There are two different methodologies for framing a residential construction. They're platform frame and balloon frame. So balloon frame construction is older, and typically those members would span from the ground all the way up to the rafter. So you would see from ground all the way up to the rafter. As far as platform frame goes, you see that second story breaks up that structural member. So you see a stud going from the floor to the second floor, but then there's a break, and then from the second floor up to the rafter. And that's beneficial because Fire burns upward, and that means that with platform framing, we've actually disrupted the path of fire travel, so we don't have an uninterrupted path of travel from floor to ceiling for fire. It actually has to burn through that floor joist or that ceiling joist before it can continue further up the house.
My name is Paul Dansbach, and welcome to Fire Engineering's Training Minutes. In this section of Training Minutes, we're going to look at a wood frame building. This building is currently under renovation. The original building is a balloon frame construction. The addition being added to the rear of the structure is platform frame. We will have the opportunity to view and understand the fire spread potential of platform frame versus balloon frame wood frame construction. Balloon frame construction is construction in which the exterior walls and interior walls run vertically from the basement past the first floor to the second floor and potentially to the attic with unfire-stopped voids. A stud bay is created by the space between the two wall studs, the exterior sheathing, and what would be the back of the interior finish. That space is open to the basement in balloon frame construction. Any fire in the basement will extend vertically through the wall, up past the ledger board, into the second floor, and potentially up into the attic. We also have the opportunity for horizontal fire extension. There is no fire stopping between the stud bay and the joist bay. The joist bay is the space created between the two floor joists. There is an opening between the end of the joist bay into the vertical stud bay. We're looking at an interior partition. It's an interior bearing partition. The partition is balloon framed. It's opened down into the basement. Therefore, any fire that occurs in the basement will extend through this combustible void space in the stud bay, the space between the studs. Vertically, it will run up into the space created by the floor joists. This partition does not extend beyond the first floor, so the fire extension in this bay will be limited from the basement to the first floor. However, once the fire reaches the joist bay, the space created by two floor joists, the fire is going to run horizontally. In the case of this structure, the fire will run to the B wall and the D wall. It will run to those exterior walls, turn vertical again in the balloon framing, and head towards the attic. Another fire extension potential with balloon frame construction is when the fire starts on a floor of the dwelling as a content fire. If the fire extends beyond the interior finish, for example, in this building, the original construction was wood lath with plaster as the interior finish. Another interior finish could also be drywall. Should the fire get beyond the interior finish, the fire will extend into the joist bay. Again, the space created by the wood joists. The fire will run horizontally in the joists and will have the same fire extension potential when the fire reaches the B and D walls of this building, where it will turn vertical and run to the second floor and the attic through the exterior walls of balloon frame construction. We are in the addition to the structure. The addition is being constructed of platform frame. Platform frame construction is one in which the foundation is constructed and then the first floor is constructed on top of the foundation. The first floor extends to the exterior wall of the structure. Then one story of wood frame studs is constructed on top of the floor. That construction method uses a 2x4 plate on top of the floor system. That 2x4 plate and this method of construction builds in the fire stopping. It is referred to as inherent fire stopping, as it is built into the structure as the building is constructed. The built-in fire protection, that 2x4 plate at the bottom, prevents any vertical fire extension from the basement up into this wall. Additionally, as we run vertically in the wall, we get to the top of the wall before our floor joists, and we see another 2x4, a double 2x4 top plate that also eliminates the potential for vertical fire extension story to story within this building.
Additionally, when it comes to two-story construction, platform framing is a little bit safer because it provides a natural scaffolding for the workers. So we can take a look at that on the next page. So we start here with our excavation for our foundation, as you can see right here. Then I go ahead and I'm going to build my first floor joists right here. Then I'm going to add my studs or my walls. And then I'm going to add that second floor frame. And then what I see, I can now use that as a platform as I construct the next walls. And then I can finally put on a roof. And that's the real basic step-by-step process of platform framing. So all house framing uses nominal 2-inch members. So think about when you're walking down the lumber aisle at a home improvement store and you see 2x4, 2x6, 2x10, 2x12. Those are all 2-inch members that we can use to frame a home. Typically, studs are placed 16 on center. They can be placed 24. We'll talk about that a little bit more in a minute. We can use 2-inch members for floor joists, ceiling joists, wall studs, and rafters. Once we've actually kind of created the skeleton or the frame of the house, we can go ahead and apply panels over the framing to lend additional support. For a floor, we can call that subflooring. For walls and roof, we call that sheathing. So think of OSB, plywood, or another similar material. Those are our sheathing or subflooring materials. So the first thing we need to do before we begin to frame a house is we have to provide a foundation. And we talked about different foundation types a few weeks ago. And so for this hypothetical example here, we've excavated a basement. And you can see here that we've poured a continuous foundation wall. And what you can see here is we've poured a continuous foundation wall right along here. So you can see that that is going to be our basement foundation system. So one thing of note that I want to point out are these guys right here. These are anchor bolts that are sticking up out of the foundation wall. They are integrated in the foundation wall, and they connect the frame of the house to the foundation of the house. So our flooring construction, we'll talk about each one of these components: sill plates or sole plates, girders or band joists, floor joists, and then subflooring. So the first item on that list is a sole plate or a sill plate. They can be used interchangeably. So how does the wall frame connect to the foundation? So anchor bolts are cast into the top of the foundation wall, which are those little pieces that I circled in red a moment ago, sticking up out of the foundation wall. So then anchor bolts come up through that sill plate, which is the structural member right here that is lying down, right by our water cooler. And then anchor bolts connect the sill plate to the foundation wall. So this is an extremely important connection because, as you know, the foundation is what anchors our home. And that's important because it allows our home to not slide off the foundation, as in that top picture, to overturn, or for failure among parts, or in a kind of more of a racking situation with our sheathing helps with. But those anchor bolts are very important to keep our home solidly connected to the foundation. Joists are used for floor framing. So joists are what you see right along here. These are all of my floor joists that lend support to the floor of my home. And then the piece that goes all the way around the perimeter of our floor plan is called a band joist or a rim board. So what you'll see here is I've got my first floor, I've got my band joist, and then I'm gonna go ahead and I'm going to tack on my bottom plate. And so this is an interior wall, so it looks a little different, but the piece that my studs actually attach to is my bottom plate, and that's this piece right here. So once I have my bottom plate, I typically go ahead and construct my wall frame lying down, and then I hoist it into place. And just like this slide before, I can go ahead and hold those in place with temporary bracing, which are those diagonal members that you see. So once I have my frame in place, I go ahead and I add a second top plate. And top plates are doubled to support the joists or rafters above. And you can see that right here, how I have two members on top of each other. And so there is a debate within the building community and the sustainability community as to whether or not a top plate is actually necessary. Those who advocate for sustainable design and advanced framing techniques say that the double top plate is overkill and a waste of resources. However, you have traditional builders who still feel it necessary. So I told you that we go ahead and we frame out a wall and then we hoist it into place, but how do we actually hoist it into place? So on this slide, you'll see a wall layout that I've come up with. So you've got your kind of the outline of the wall here. You'll see some hidden lines right here in the middle here and on this right-hand side, which denote that there are studs there, or special areas of kind of interior partitions that are hidden by the wall that's facing outward. And then there's also a door and a window. So step one is I go ahead and I place frames at special locations. So what are special locations? Special locations are corners, like you see here, anywhere that there's a partition that will kind of dead end into the wall, and then any opening that you put in the wall. So doors, a window, a pass-through, those are all kind of considered special locations. So what you'll notice too is that I also have to do some additional framing work around these doors and these windows. So anytime that you cut a hole into a wall, that means it becomes weaker. It can't support the load above it because you've cut a hole in it. So what you need to do is you have to go ahead and provide a header. And a header is typically a larger structural member, maybe a 2x6, 2x8, just depends on the size of the opening, that distributes the weight around the opening and then down each side of it. So this header distributes the weight across the opening and then down each side. And then you'll also notice some of these jack studs that help hold up that header. After I have my special openings all framed in, then I'm going to go ahead and place my regular 2x4 studs at 16 on center. Again, in the world of sustainability, there are those that argue if I use a 2x6 stud, which is a little larger, I don't need to place them so close together. I can place them a little bit further apart. So if you work for a framer that employs or a builder that uses 2x6 construction, the typical spacing for that is 24 inches on center. And on center means from center of stud to center of stud, so right in the middle. So once I have my special openings framed, then I'm going to add studs that are 16 on center all the way down. Now, what you'll see in this case is that not every space is equal 16 on center. So I probably have 16 here, 16 here, but then right here, maybe I have only 8. But it's important to note that I can't, with 2x4 construction, have a span that's greater than 16. So if this was 16 and this is 8, I obviously have a span that is wider than 16, which means now I have some structural integrity issues. So I do have to add in this last stud here, even though maybe it's only 8 inches away from its next partner over. Once I've got my wall framed, I hoist it into place and I add some diagonal bracing, which allows my wall to kind of stay upright and not wobble out of place. So then I'll eventually add my second top plate, and then I can go ahead and apply exterior sheathing. Once I'm done adding that second top plate, then I kind of start the same process all over again. I'll add floor joists just like I would on my first floor, and then I would add a subfloor, and then I would build my walls lying down for my second floor and then put those in place as well. So here's an example of that. I have my upper platform framing happening, and eventually once that subfloor is applied, I'll go ahead and construct my walls like you would see right here. And again, here's that benefit of platform framing, because now each floor makes a very convenient work surface for me to build the next set of walls. Once I have my second story walls framed, now I can go ahead and frame in my roof. So I've got my ceiling joists. Now it's time for me to go ahead and add a roof to my structure. Typically a knowledgeable framer can lay out all the cuts and how they're sloped and what angles pretty quickly and pretty easily. However, today we also have the capability for to utilize prefabricated trusses. So if you've ever been driving down US 1 and seen a large semi with a bunch of wooden triangles on the back, typically those are prefabricated roof trusses. And then finally, once my roof has been constructed, I can go ahead and apply exterior sheathing to the whole structure.